afternoon, everyone. Today I'm going to talk about intrinsic dimension for very high cycle fatigue or high strength steers. And I think first I raised 4 questions, and then I tried to answer such 4 questions. And perhaps most of them know that what is very high cycle fatigue is the fatigue failure beyond 10 to 7 cycles of loading. And for very high cycle fatigue, the crack initiation is almost from the interior of the specimen. And there always a kind of morphology called fish eye. And in the center, there's a, which is going, may I use your pointer? Yes. No, I mean, your voice. Stick.
No, stick.
It is more useful. There are always a kind of morphology called fish eye, and in the center is a morphology of rock surface called fine grain area, and is due to crack initiation from the intrusion. And I said that I would raise 4 questions. The first is if there's an intrinsic, if there's a characteristic dimension for this kind of crack initiation. And the second question is if there's kind of characterization dimension, then I ask such kind of dimension, if it will contribute to the fatigue life, what is the fatigue life contributed by this dimension? And the third question is fatigue, the crack growth rates within this area. And the final question is what is the mechanism of this kind of formation due to the crack initiation? Okay, now the first question is the characteristic dimension for crack initiation. And we measure this type of morphology, and to show the range of FGA is between 40 and 100 microns. It's quite stable, so there. And then we try to plot this kind of relation between the size of FGA and the size of maximum stress. And we note that these 2 values, these 2 parameters, are controlled by this relation between delta K and loading stress and the size of the crack or defects. And we may put 2 bounds. One is the lower bound of 4 megapascal square meter, and the upper bound of 6 megapascal square meter. And we put our data and quite a number of data from literature, and we found that almost all the data within these 2 bounds. Of course, first we measure this value of delta K FGA is almost between 4 and 6 megapascal square meter, and also the other data from the literature or within this range. So at this stage, we said that there is a characteristic dimension for such kind of crack initiation. It is the size of FGA. So if we have this kind of dimension, we may use this value to estimate the fatigue life within this initiation period And also, we may be able to calculate the crack growth rate within this initiation region. So this is the first question I answered. And then we based on the plastic size and crack tip and also the characteristic size of the material. And we may get this formula showing the delta K FGA is a function of shear modulus and the burst vector of the material. This formula is very similar to the one previously presented by Paruda and People's group. And we may get this value to show the value of delta K FGA is about 5.5 megaparts per square meter for steels, and for aluminum alloy is about 1.9. And this value is quite well in agreement with experiments. So it means that the characteristic dimension of the material due to this kind of related to this kind of failure is related to this kind of characteristic value of parameter for crack initiation. And for this kind of consideration, we may calculate the fatigue life contributed by crack initiation. So first, we may see that the total fatigue life is contributed by three parts. One is initiation due to FGA. The other part is from FGA to the boundary of fissure. And the third part is from the boundary of fissure to the final point or critical size of the material. So it means that the initiation life may be obtained by this simple formula of total fatigue life minus n sub 1 and n sub 2. N sub 1 is due to the life from the boundary of FGA to the boundary of fissure, and the n sub 2 is from this to the final fracture. So from this simple consideration, we may get the fatigue life contributed by crack initiation in the very high side fatigue regime. It's more than 95%. So this is very important result, showing that fatigue initiation period is very, very important stage for this kind of failure. And then we are able to obtain the crack growth rates in this region. And the results show that the crack growth rate is very, very slow. It's between 10 to minus 12 and 10 to minus 30 meters per cycle. So a long fatigue life consumed in this initiation region, and also the crack growth rate is very, very slow. So I have answered the second and the third question. And then I try to answer the fourth question. What is the mechanism for this area, for this region of crack initiation? We propose that this area is kind of fine granular layer. And first, we use the method of ion polishing to see the profile of this initiation region, showing that there is a kind of layer of fine granular structure with about 650 nanometers. And then we use the method of focus ion beam fit technique to very carefully cut the small samples from the initiation position to see the microstructure in this area by TM. And the results show that just underneath FGA region is a kind of this, something like this continuous circle, and away from the surface is a kind of isolated spots, showing that it's a kind of fine grains there, and this coarse grain, meaning that here this diffraction pattern means that only a single grain within the diffraction area of about 200 nanometers. And this is a TM photograph showing underneath the FGA surface is a kind of fine grains, and the average grain size is about 50 nanometers. And we use another sample to see the two surfaces of the fracture surface. We may call positive and negative surface. And we cut the specimen, the fifth sample from the same location to show that underneath GA at the same location, there are continuous or discontinuous circle within the diffraction area, showing that very, very small grains within the area of 200 nanometers. And away from the FGA is within fisheye, but outside FGA is a kind of isolated spots, meaning single grains in this area outside FGA. Therefore, we propose the model. Oh, sorry, there's something missing. We propose a model of numerous site pressure to cause such kind of fine granular area. It is a kind of numerous site pressure between originating crack surfaces. And first step is the crack initiation. And there's a kind of contact or pressure between the crack surfaces and then to cause the fine grains in the fracture surface. So if we have this kind of mechanism, we may have two inferences or two predictions. The first is that the previous ones, we obtained the result for a strength ratio of -1. And the predictions are, the first, for plus stress ratio, because there are less contact or less crack closure effect. So such kind of fine granular will be less possible. And the second prediction is, even for minus stress ratio, but the site number, the loading number is not sufficient, this kind of morphology will also be less possible. Then we did some extra experiment to show for -1 stress ratio, but with small number of 10 to 5 sites loading, the FGA morphology is almost disappeared. And for the ratio of +0.3, we also do not see FGA morphology. And this also, we use the fifth technique to cut the small samples to show that for -1 and 10 to 5, it's not large number loading cycles. It's a kind of elongated or slightly elongated diffraction pattern, showing perhaps just a couple of grains within the diffraction area. And for -0.5, it's a kind of discontinuous circle. It's still a few grains within the diffraction area. But for the strip ratio of plus 0.1 and plus 0.3. Underneath the fracture, the crack initiation area, there are all isolated circles, isolated spots. There, showing just a single grain there. So this to answer the answer our two predictions. So this is the final slides of my presentation. I just would like to show you a picture of very high angle fatigue of ice spheres. Is due to the initiation, the interior initiation. And there are three transition points for this kind of process. And the first transition point is the total important. It is crack initiation. The homology is a fine-grained area, and it may consume more than 95% of the heat life. And the crack growth rate is very, very slow. The value is between 10 to minus 12 and 10 to minus 13 meters per cycle. And the main reason is due to the crack content of pressure. So that's my presentation. Thank you.